So now that we've finished our discussions of collect, let's turn our attention to reduce, which is one of the other powerful and common terminal operations you get with Java streams. So we'll start off by just giving an overview of what reduce does, and then we'll show some examples. Again, we'll use the Hamlet program, but we'll do some terminal operations here that are a little different from what we looked at before. So what reduce does is it typically returns a primitive or a single value. You could have it return other things besides primitives, but it's very commonly used to return primitive values, things like longs or ints or doubles, or the other variants like integer and so on that are the so-called reference types as opposed to the primitive types. So here's a simple example we're going to use where we're going to end up with a map of names to the length of the names. We've seen this example before, so that's no surprise. And then here we're going to go ahead and use that particular map that we produced by this means in order to sum the length of the names of characters in Hamlet. So again, just to follow the same example, it's a little bit contrived, but it helps to keep things going in a consistent way. So what we're going to do in this particular case is we're going to take that map that we got here, and we're going to convert the map's values list into a stream of long values. So the .values factor method on a map will end up giving basically back I think it's actually a set of values. We turn that set into a stream, and then we're going to go ahead and take those values and sum them up by using the reduce operation. So we'll talk in more detail about how to read this particular piece of code in a second, but that's what we're doing. We're summing the name lengths in the values stream. The value 0 that's passed in here is the so-called identity value. And it does two things. It provides the initial value for the reduction, so we start at 0 in this case. And it's also the default result if the stream has no elements in it. Now, in this case, there will be elements in the stream, but that's not always the case. So if there are no elements, that's the default value that gets returned, even if there's nothing in the stream at all. And then the second parameter is what's known as an accumulator. And this is a stateless function that combines two values into a single so-called immutable reduced value. And the fact that it's immutable is really important. And I won't spend a lot of time on this right now, but when we talk later about parallel streams, you'll see why the assumption of immutability is super important. And immutability is just a fancy way of saying once the value is set, it can't be changed, or it shouldn't be changed. Or if it changes, then problems are going to arise. So you could also use a lambda expression here. This is using a method reference. This is the sum method that comes out of long. But you can also use a lambda expression. I tend to like method references a lot more because I think they're more intuitive. But don't be surprised if you see code that looks kind of like that. There's also a 3-parameter version of reduce, which is commonly used with parallel streams. And if you want to know what the map reduce paradigm is, there's a little video you can watch here. The stuff that we've been talking about is in the class of map reduce style things, although typically when people talk about map reduce in practice, they're thinking more about cluster computing. For example, what Google does when you do a Google search, they go and do those searches over a wide swath of databases and then merge all the results together. So they map your search query into a bunch of different places that run in parallel on different computers in a cluster and then return the results. The kind of stuff we're typically talking about here is running within a single process. So you're limited often by the number of cores, which could be extensive, but not as much as a huge cluster, of course. So in this particular case, as usual, we're going to get our list of characters that are starting with H and capitalized and sorted properly and so on. And then down here, in parallel, we're going to go ahead and give an initial value of 0. And then we're going to pass in the accumulator, which is going to keep a running sum of the lengths of each of the character names. And then this third parameter is the reduction that goes ahead and adds those things together. The difference between the sequential and the 2-parameter and the 3-parameter version is sort of subtle. And you can almost always get away with using the 2-parameter version. So I recommend doing that unless there's something particularly relevant that you need to use the 3-parameter version for. Now, something else to note with the reduce operation is you can actually get around the need to use it if the elements that you're trying to reduce happen to be primitive values. So for instance, here we're going to use the sum terminal operation, which basically is reduce, but it's a shorthand if what you're dealing with are going to be primitive types. So here's how this works. We convert the map into a stream of long values by using the dot values factor method followed by the dot stream operator, which is a factory method, of course. And then we're going to use the map to long operation. This is an intermediate operation that, in this case, will map the stream of longs with a capital L into a stream of longs with a lowercase l. And you might go, aren't those the same thing? Strangely, no. Java differentiates between reference types and primitive types, and then it's got all these weird conversion operators that convert back and forth between them. So this is converting a stream of longs with a capital L into a stream of longs with a lowercase l. And once they're longs with a lowercase l, we can then sum them to get a single result. So sum expects to have a stream of long primitives to work on. So that's the end of that particular part. We'll talk about another discussion here in the second part.